All right, let's talk about graphing the secant and cosecant. Remember, these guys are the buddies. This guy goes with cosine, and this guy goes with sine. They're the reciprocals. And I call them the buddies because they go together, right? Buddy system. Okay, here's what these graphs look like. Now, these are the easiest ones to graph. As long as you can graph sine, then you can graph cosecant. Here's how it works. Your basic sine graph starts at an intercept, ends at an intercept, has an intercept in the middle, and then has a maximum and a minimum. That's a basic sine graph. So your sine graph, one cycle of it looks like that. Here's how cosecant, its reciprocal, works. Everywhere there is an intercept of sine, that means sine of that angle equals 0. Well, that's 0 over 1, which means the cosecant is 1 over 0, or undefined. Now, when you're talking about graphing, undefined means an asymptote. Whoop, whoop. So the first step to graphing cosecant is to get your sine graph up there, and then everywhere there's an intercept, we're going to make these a little bit bigger. Everywhere there's an intercept, like right here, for cosecant, that's an asymptote. Oh, here's another intercept for sine. That means that's an asymptote for cosecant. Another intercept for sine means another asymptote for cosecant. So intercepts of sine equal asymptotes of cosecant. So these guys, intercept of sine becomes an asymptote of that. So any intercept becomes an asymptote. Okay, the next portion of it is what are called these cups right here. Anywhere there's a maximum on sine becomes what's called an up cup. So maximum right here, it's literally like I'm taking this little hump right here and flipping it upside down. And likewise for the minimum, it's coming down in this little valley on the sine. I'm just going to take that and flip it down. That becomes what's called a down cup. So this is an up cup and a down cup. So when you look at that, you can identify all the same pieces, right? Domain, range, intercepts, and asymptotes, and period. Let's talk about each one of those. So domain. Domain is all the x's that can be plugged into the function. Well, we know that there are asymptotes, which means all real numbers except x cannot be equal to, now one cycle, it's 0, pi, 2 pi. If you were to keep going, the next one would be at 3 pi, and so on, including the negative areas. So 0 pi, 2 pi, 3 pi, and so on. But it also holds true for the negative direction. If you look over here, there's going to be another asymptote at negative pi. There's going to be another one over here at negative 2 pi. If sine keeps going, it's periodic, keeps repeating, that means cosecant is going to keep repeating. So we write it like this. All real numbers except x cannot equal, and then you can either use n or k, it really doesn't matter, k pi, where k is an integer. So k could be 0, 1, -2, -400. Any multiple of pi is going to be an intercept for this cosecant. Okay, the range, instead of going from -1 to 1 like sine, it's actually going to be from -infinity up to 1, combined with, up to -1, combined with 1 to infinity. And it does actually, it is defined at that point right there, the -1 and 1, so it's okay to call it that. Okay, intercepts are anywhere it crosses the x-axis. So my cups right here are my actual graph. Asymptotes are just like dividers. It will actually never have an x-intercept. I can't say never. If you start shifting that graph up and down, then it might have an intercept. Okay, asymptotes are at wherever x equals k pi, where k is an integer. And then the period for cosecant is the same as the period for a regular old sine at 2 pi. That's going to change. If there's a change in the period to the sine, then it's cosecant has the exact same sign always. All right, that's cosecant. Now secant is the exact same idea, but this time it goes along with cosine. So basic cosine graph says I start at a maximum, I end at a maximum, and I have a minimum in between, and then my two intercepts. So here's what the cosine looks like. That's just one cycle of it. Everywhere there's an intercept, there is again going to be an asymptote. So here's an intercept for cosine. That means an asymptote for secant. Here's an intercept for cosine. That means an asymptote for secant. And there's going to be one over here. We're really just concerned about that one first cycle, but just so you kind of visually get what I mean by asymptote, is it continues to go. So any, whoops, we need a regular. Any x-intercept becomes an asymptote. This is for cosine. Becomes an asymptote for secant. Right? That means the domain is all real numbers except x is not equal to pi halves, 3 pi halves, and if you continue on, it's at 5 pi halves, and also the negatives. So that's actually going to be r equals, or sorry, all real numbers are, except x cannot equal, now I'm just going to write this out in words. I'm not going to write it with a k so it doesn't get confusing. Odd multiples of pi halves. Notice how it's 1 pi halves, 3 pi halves, 5 pi halves, and so on. And the negatives as well. So negative 19 is an odd number. Negative 19 pi halves would not be part of it. That would actually be the asymptotes down here. So odd multiples of pi halves. That just means any odd integer, if you throw it up in front of that pi halves, that will be an asymptote. Okay, period for one cycle is just like cosine. It's a regular old 2 pi. Intercepts. You don't have any intercepts. It's never going to cross it unless you have shifts. That's true. But for the basic secant, there's no x-intercepts because there's those cups. So here's my asymptotes. Everywhere there's a maximum, you flip that piece up and it becomes an up cup. If it's a minimum, you flip those pieces down and it becomes a down cup. Now, if you'll notice for cosine, it's a little bit weird because this is an up cup, but it's only half of an up cup. The other half of your up cup happens over here. And then down here, you have a full down cup. Now, those are the words that I use to describe them. If you go out more cycles, right, you'll get a full cup over here on this left side, negative, and so on. But we're just concerned about this one cycle right here. So range, again, it's just like before. It's going to be that negative infinity up to -1, including -1 because it is defined at that value, with 1 to infinity being the rest of it. Okay, so using that idea, here's what we're going to do. In order to graph one of these guys, secant or cosecant, your period is still 2 pi over b. You're going to start with sketching one cycle of either sine or cosine. Sine for cosecant, cosine for secant. You're going to apply reflections and phase shifts. But we're going to do the midline changes very, very last. When we start putting in intercepts and flipping our cups, it's easier to do that before we start shifting up and down. It makes more sense to do it this way. Less thought put involved in it. And then once you get that graph up there, you're going to put in your intercepts. You're going to put in your asymptotes anywhere there's an intercept. And then you're going to start flipping your cups. So let's start. This is secant, which means cosine. So before I get secant in there, I'm going to graph y equals -2 cosine of x. Okay, identifying my pieces, I've got an amplitude of 2. It has been reflected. My period is 2 pi over 1. No change there. There is no midline shift or a phase shift. Okay, so regular old graphing here. I'm going to count out 4 spaces on my line. 1, 2, 3, 4. That's where I'm going to put my period. 2 pi. Then I would have 3 pi over 2 here, pi here, and pi halves there. This is kind of squished together. If you wanted to spread it out and do every second line, you could do that as well. Okay, I've got an amplitude of 2, so that means I've at least got to go up here to 2 and down here to -2. And then I'm going to graph my cosine. Now remember, with these guys, I graph it one piece at a time. I'll do the 2 cosine of x. And then I'm going to go in there and I'm going to apply that reflection there, right? So I'm going to now take those pieces. Any maximums will become minimums. Intercepts stay the same. Minimums become maximums, and so on. So right now, here is one cycle. Whoops, I hit the wrong line. That guy goes here. Okay, so here's one picture, one cycle of my cosine graph. Okay, got that part, including that reflection right there. Now I need to change it into secant. So secant says everywhere there is an intercept, you need to put an asymptote. Okay, here's an intercept right here. So that becomes an asymptote. Intercept, asymptote. Okay, and that's all in this one cycle. Then you're going to take every maximum, and it's going to become an up cup. Should be more curved than that, sorry. Ooh, nice and sloppy. Let's try that some more. Whoops. Ah! Phew! Got a little scared there. Take that guy off. Take that guy off. We're just going to stick with it instead of losing it. And then any minimum has to become an any minimum becomes a down cut. Now we only have one side. Gosh, this thing is really just trying to irritate me. Now remember, with cosine, it's weird because it actually only has half cups at the ends of it. It's literally, I took this black line right here and I flipped it upside down. I did its reciprocal. So this green graph right here is my final graph of -2 secant of x. I graphed cosine, put in asymptotes anywhere there's an intercept. Anywhere there's a maximum, you flip those lines upside down, reciprocals, right? And then down here at any minimums, they get flipped upside down as well, but you're supposed to stay within that one period for one cycle. Let's try another one.